Welcome back to Research Methodology and Nanomaterials. Under Research Methodology and Nanomaterials, we have discussed about crystal structure completely. So, within the crystal structure, what are the problems we are getting? Today, we are going to solve the problems on crystal structures. First one, first problem. Calculate the number of atoms per unit cell of a metal with lattice parameter 2.9 angstroms. Given molecular weight is 55.85 kg per meter cube. Density is 7870 kg per meter cube. And Avogadro number is 6.023 into 10 to the power of 26 kilo per mole. Here, the problem, first we need to understand how many number of atoms per unit cell of the metal. So what they are asking, number of atoms per unit cell first they are asking. So here what they are asking, and what are the parameters they are given. Lattice parameter is 2.9 angstrom, which is 1 angstrom is equal to 10 to the power of minus 10 meters. So 2.9 into 10 to the power of minus 10 meters. And what is the molecular weight they have given? Molecular weight is M is 55.85 kg per meter cube, and the density is 7870 kg per meter cube, and Avogadro number is 6.0263 into 10 to the power of 26 kilo per mole. What is the formula we are having? Density, and here we are having formula rho is equal to n into m by n is the number of atoms per unit cell, m is the molecular weight into n is the Avogadro number into value. Value is equal to a cube is the lattice parameter. So cubics. Now we need to calculate the number of atoms per unit cell. So n we should find out. N is equal to nothing but n is equal to rho into n, rho into Na into value is equal to a cube divided by molecular weight. So we know the all other parameters. So we can remove. We can calculate the number of atoms per molecule. So here density we already know 7870, and Avogadro number is 6.023 into 10 to the power of 26, and lattice parameter is 2.9. Volume is equal to a cube. Volume is equal to a cube. A is the lattice parameter. A is equal to 2.9 into 10 to the power of minus 10 whole cube. So we can write this one as 2.9 whole power of cube 3 into 10 to the power of minus 10 whole power of 3 is nothing but 10 to the power of minus 30. So lattice parameter we get to know as per this, and molecular weight is 55.85. So we are getting number of atoms per molecule is 2.06. 2.06. Nothing but approximately equal to 2. This is nothing but number of atoms per molecule in simple cubic is 1. simple cubic is 1. Number of atoms per molecule in body centered cubic is 2. Number of atoms in face centered cubic is 4. So these nothing but what is the metal? Here the unit cell of the metal with the lattice is nothing but the number of atoms is 2. This is nothing but it is a body centered cubic structure. Now we are going to the second problem. Second problem is chromium has body centered cubic structure. Nothing but here number of atoms is equal to 2 for body centered cubic structure. Atomic radius means atomic radius for body centered cubic structure R is equal to root 3 by 4a. Nothing but so here atomic radius R is equal to root 3 by 4a and calculate the free volume per unit cell. Free volume per unit cell they are asking to find out. So what is the parameters? First atomic radius R is equal to 0.1249 nanometers. Nothing but nanometers means 10 to power of minus 9. Free volume per unit cell they are asking to calculate. So how we can calculate free volume per unit cell for body centered cubic structure means free volume means atomic packing fraction is equal to how much we got for body centered cubic structure. Atomic packing fraction is equal to 0.68 we got for atomic packing fraction for body centered cubic structure. So free volume or void space or empty space is nothing but atomic 1 minus atomic packing fraction 1 minus atomic packing fraction into 100 is nothing but we are getting for points 1 minus 100 means here we are getting for 32 percentage is the free value. So here we are bringing to the free volume per unit cell means 0.68, 0.32 is nothing but 100 percentage. So we are taking for 0.32 for free volume means one how much atoms is able to fill in a body centered cubic structure. Atomic packing fraction is 0.68 at free volume in 1 minus atomic packing fraction is equal to 1 minus atomic packing fraction is equal to 1 minus atomic packing fraction is equal to nothing but free value per unit cell for body centered cubic is 1 minus 0.68 is nothing but we are getting for 0.32. So volume they are asking. So volume is for simple cubic body centered and simple cubic body centered and face centered cubic structure for volume formula is volume is equal to a cube. So here 0.32 into a is the atomic radius r is equal to we need to find out a is equal to nothing but a is equal to 4r by root 3. So atomic radius r is equal to how much? 0.4 into 0.1249 nanometers divided by root 3. So here we are getting for A is equal to 4R by root 3. 4 into R is equal to R is equal to 0.1249 into 10 to the power of minus 9 divided by root 3. So we are getting for 2.884 is the lattice. A is equal to 2.88 2.884 into this one. So 0.32 into A cube means 2.884 into 10 to the power of minus 10 whole cube is nothing but 7.676 into 10 to the power of minus 30 meter cube is we are getting final answer. Now third problem. Copper has face-centered cubic structure. Face-centered, how many number of atoms? N is equal to 4. And the atomic radius R is equal to 1.278 angstroms. Calculate the density of a copper crystal given molecular weight is atomic weight of copper is 63.5. So here it is given atomic radius R is equal to 1.278, atomic weight is equal to 63.5, and face centered cubic relation R is equal to root 2 by 4a. So here we can write as a is equal to 4r by root 2. Here 4r we can also write as 2 into 2 into r by root 2. So this 2 also we can split root 2 into root 2 into 2 r by root 2. 2 get cancelled. So we are getting resultant 2 root 2 r by 2 root 2 r is the value for a is equal to 2 root 2 r. This is the formula we are getting. So this expression we are going to substitute in the formula where we got for lattice parameter to calculate. So what they are asking? Density to find out. So A is equal to nothing but A is equal to root 2 into 1.278 into 10 to the power of minus 10. It is already in angstrom, so we can keep it angstrom. 1.278 into 2 root 2. Nothing but we are getting for 3.74 angstroms. Now, Avogadro number standard value is Na is equal to 6.023 into 10 to the power of 26 kilo per mole. And we are having the formula density they are asking to find out. Rho is equal to N into M by Na into V, whereas where V is nothing but A cube. So V is equal to A cube. This is the formula we are getting. So here resultant parameters if we are substituting, what we will get, rho is equal to N. N is equal to how many number of atoms? For face centered cubic, N is equal to 4. 4 into molecular weight, how much? 63.5 divided by Avogadro number is 6.023 into 10 to the power of 26 kilo per mole. And A is equal to 3.614 angstroms whole power of cube. is nothing but we are getting for 8.92 into 10 to the power of 3 kg per meter cube. Finally, we are getting the value. That's all. Now, next problem we are going to solve about state. State that in a simple cubic lattice, the separation between successive lattice planes are 100 plane and 110 plane, and 111 planes are in the ratio 1 is to 1 is to 1 is to. So we are having the formula is these are the ratios. So we need to calculate interplanar spacing between D and A and HKL planes relation. So the interplanar spacing between the formula is D is equal to A by square root of H square plus K square plus L square. So which planes they are asking? One is 100 plane, another one is 110 plane, third one is 311 plane. So respective planes we are substituted. A we don't know. So to find out point of view, what we are getting D1100 plane, we are getting A by square root of 1, A by square root of 2, A by square root of 3. So we are getting resultant values 1 is to 1 by root 2 is to 1 by root 3. So finally we are getting for 1 is to 0.7071 is to 0.577, we are getting the final values. That is the fourth problem. Now we are going to find out the Miller indices of a set of parallel planes which makes intercepts in the ratio of 3a is to 3a is to 4b is to in if a plane parallel to x-axis parallel to axis, then corresponding to the intercept is infinity. Means 3a 4b on x and y axis respectively. These all are parallel to the z axis. Z axis is nothing but just we will see in later points. So nothing but we are representing the notation P is to Q is to R. Nothing but 3A is given, 4B is given, but Z axis is infinity. So we are representing Z axis as infinity C. Infinity C, nothing but. So we are getting for HKL, nothing but HKL is reciprocal of 1 by P, 1 by Q, 1 by R. So here we are getting for 1 by infinity. These not 4, these 1 by infinity. So we are getting for 1 by 4, 1 by 3, 1 by P is nothing but. Therefore, we are getting the final Miller indices is 430. That's all. So, reciprocal, we are taking for PQ and R point of view LCM. So, 3 4 ja 12, 12 by 3, 3 4 ja 12. So, 4 we are getting 12 by 4, 4 3 ja 3 we are getting infinity 12 by infinity nothing but 0. So we are getting the Miller indices are 430. That's all. So sixth problem in triclinic crystal means nothing but we are having for A not equal to B not equal to C. A not equal to B not equal to C, nothing but is triclinic, and alpha not equal to, beta not equal to, gamma not equal to 90 degrees is the triclinic system. In triclinic crystal, the lattice plane makes intercepts of lengths A, 2B and minus 3 by 3C by 2. So we need to find the Miller indices of the plane. So intercepts are given are A, 2B minus 3C by 2. So what we are having the formula PQR is equal to, means these PA and QB is nothing but Q is 2 and R is equal to minus 3 by 2. So we are representing, therefore PQR are nothing but 1 is to 2 is to minus 3 by 2. Now we are taking the reciprocal of PQR. So we are getting the LCM denominator, numerator. So we are getting what value? Minus 3 by 2. So 2 2 is 4. We are taking the reciprocal of this value. So we are getting finally 6 is to 3 is to minus 4. These based on LCM, and afterwards numerator we are dividing with the respective values, then we are getting the resultant 6 is to 3 is to minus 4. So 4 we can represent Miller indices as minus 4 instead of, we are using the notation Miller indices are closed in parentheses, and minus we can represent as a bar. That's all. This is the problem about triclinic crystal Miller indices of the plane. And seventh problem is determine the spacing between 100 planes, 110 planes, and 111 planes in a NaCl crystal having a lattice constant is 5.64 angstrom. So similarly, interplanar spacing formula is equal to D is equal to A by square root of h square plus k square plus L square. So the respective planes, 100 plane means D is equal to A by A is equal to how much they are given? 5.64 angstrom. D is equal to A by root 2. A is equal to how much? 5.64 root by 2. Nothing but 3.988 angstrom. D triple 1. Nothing but A by root 3. Nothing but here A is equal to 5.64 divided by root 3 is nothing but we are getting the resultant value 3.256 angstroms respectively. So we are got for 100 plane is 5.64, 110 plane point of view interplanar spacing is 3.988 angstroms. For 311 plane we are getting the resultant value is 3.256 angstroms respectively. Now we are moving to the eighth problem. Here what they are asking, the distance between 110 plane means the distance between, first formula is D is equal to A by square root of h square plus k square plus L square. So what they are given, so 110 plane point of view A by root 2 we are getting. For body centered cubic means n is equal to 2, and they are telling the distance is 0.203. What they are asking, calculate the size of the unit cell, and also they are asking to find out the radius of the atom. We will see in the next steps. Given Miller indices is 110 plane, and D they are mentioning D is equal to 0.203 nanometer. What is the formula we are having for D and Miller indices point of view? D is equal to A by square root of h square plus K square plus L square. So this is the formula. So D already they are given. So we can able to find out A. A is equal to D square root of H square plus K square plus L square. So nothing but we are getting D is equal to 0.203 into nanometers 10 to the power of minus 9 meters square root of 1 square plus 1 square plus 0 square is nothing but root 2 0.203 into root 2 nothing but we are getting for A is equal to 0.287 nanometers. Nano nothing but 10 to the power of minus 9 meters. So what they are asking, next step, radius of the atom. For body centered cubic, what is the formula? R is equal to root 3 by 4a. We already get to know from interplanar spacing we got A is equal to 0.287 nanometers. So we are substituting root 3 into 0.287 by 4 is nothing but we are getting the radius of the atom is 0.1242 nanometers. Now we are radius of the atom is what is the formula? Radius R is equal to for body centered cubic R is equal to root 3 by 4a. Root 3 by 4a. So we already get to know A is equal to 0.287 nanometers. So R is equal to root 3 into 0.287 into divided by 4 is nothing but R we are getting for 0.1242 nanometer. Size of the unit cell for body center cubic volume is equal to A cube. So A cube is nothing but A already we get to know 0.287 nanometers. So we can able to calculate size of the unit cell. We are getting finally 23.63 10 to power of minus 30 meter cube. Last problem. A copper has face-centered cubic structure. Means how many number of atoms for face-centered cubic? N is equal to 4. N is equal to 4. With the atomic radius, what is the atomic radius? They are asking for face-centered cubic. R is equal to A by 2 root 2 is the formula for face-centered atomic radius. R is equal to root 2 by 4A. So here atomic radius R is equal to 0.1278 and calculate the interplanar spacing for 111 plane and 321 planes. So what are the parameters they are given? One is face-centered cubic number of atoms is 4. Atomic radius formula is R is equal to root 3 by root 2 by 4A. So that one we can also rewrite as R is equal to A by 2 root 2. So finally A is equal to what is the value? A is equal to root 2 into R. R is we got 0.1278 nanometers. So after substituting what is the final value we got? 3.61 angstroms we got for lattice constant. So, what are the plane they are asking to find out? For 111 plane, D is equal to A by square root of H square plus K square plus L square. So, we are substituting D is equal to A. A we already got for 3.61 angstrom divided by square root of 1 square plus 1 square plus 1 square is nothing but we are getting for 111 plane 0.2086 nanometers. For 3 to 1 plane, D is equal to A by square root of 3 square plus 2 square plus 1 square is equal to. So we already know for A is equal to 3.61. So we got for finally for 3 to 1 plane we got for 0.0965 nanometers. This is the formula. And the last problem, potassium chloride is having potassium chloride is nothing but KCl is having the face-centered cubic structure. Face-centered cubic structure having a density rho is equal to 1980 kg per meter cube, and molecular weight they are telling 74.6. Calculate the first, what they are asking, calculate the distance from one atom to the next atom of the same kind. And second problem, they are asking the distance between the adjacent atoms. So what are the parameters are given here? First one is density is 1980 kg per meter cube. For face centered cubic, how many number of atoms? N is equal to 4. And molecular weight they are given is, molecular weight is 74.6, and there are, and Avogadro number is 6.026 into 10 to power of 26 kilo per mole, and face centered cubic number of atoms is 4. We are having the formula A is equal to N into M by rho into Na whole power of 1 by 3. Just we are substituting the parameters, we are getting for the lattice constant is A is equal to 6.3 angstroms. Now we are calculating distance between the atom of the same kind of potassium chloride is 6.3 angstroms. And now they are asking for second one is distance between the adjacent atoms is R is equal to A by 2. So A by 2 means 6.3 divided by 2 is nothing but we are getting for 3.15 angstrom. That's all. Thank you all.
Like, share and subscribe. Hit the bell icon for more updates.